Welcome to Teja Statistics. In this class, we are going to learning about the unit number 2, that is probability. In general, what is the probability? Probability in the sense we are going to have the measurement of uncertainty. Okay, so the general definition. In our syllabus, what we have about the probability, we have the Boole's inequality and Bayes theorem and basic simple definitions of the probability. You can see this is the definitions and syllabus of the probability in our unit number 2. Next, let's see the introduction about this probability. The concept of probability is used by each one of the knowingly or unknowingly in our daily lives. So you may see the rainy season, how you are going to find out, how you are going to guess about the rain. Okay, the train may arrive at half an hour. What is the probability of occurring of the chance? Okay, like there are so many examples on in our day-to-day life. Next, the scope of probability. Okay, these statements involve an element of uncertainty. Okay, a measure of uncertainty is provided by a branch of applied mathematics called the theory of probability. The probability measures the numerically, the happening of the event. Next, you can see the scope of the probability. The probability is an important tool in the areas of engineering, computers, and physical and the social sciences, biological sciences, and business management sciences. Okay. Next, basic concepts of probability. So you have to learn some basic concepts in the probability. First of all, what is an experiment? The activity that yields a results or an outcome is called an experiment. In tossing of a coin, we are going to have the head and tail. So these are the experiment and their outcomes. Also throwing a dice. Okay, measuring the length of a table, playing a pack of cards, like that. Next, types of experiments. How many types of experiments are there? So what is the types you have to see here? That is deterministic experiment and undeterministic experiment. Undeterministic experiments are can be called as the random experiment, or we can say it as the results what we can how we can't able to measure. Okay, that type of things comes under this undeterministic experiments. You can see the definitions with some examples also here. In adding two numbers like 3 and 4, so this is a deterministic, you can easily tell. Okay, undeterministic with an example. In tossing of a coin, the outcomes are already known. That is first one, head and tail. Okay, but exactly outcome we can't able to say. That type of things comes under uncertainty and deterministic experiments, or we can say it as the random experiments. Okay, trial. The conducting of an experiment uh, only once is called trial, and the repetition is also be called it as a trial. Okay, next, what is an outcome? The result of an experiment is called an outcome. Okay, a sample space, we have to see some more definitions here. The sample space, the set of all possible outcomes in a random experiment, is called as a sample space. It is denoted by S. Each element in a sample space is called as a sample point. Okay, The sample space is also called as a universal set or event space and the probability set. In tossing of two coins, the in tossing of two coins, the sample space S is denoted by head and tail, or a tail or head and tail and tail. It is denoted by with one set, and that is capital S. In throwing of a dice, the sample space is also B. You can see here. Next, event. The event is a set of a single or many outcomes of a random experiment. Any subset of sample space is an event. Okay, in tossing of a coin, getting the head. In tossing of two coins, getting at least one tail. In throwing of a dice, getting same point on the two faces. Okay, so these are all the experiment and a trial and probability and their events. Okay, results, like that. These are all the definitions. Next, see. So the events are having so many types: simple, compound, exhaustive, mutually exclusive, equally likely events, independent events, dependent events, sure event, impossible events, a complementary event, and a random event, and overlapping event. In events, we have this much of we have this much of different types. That is simple event, compound event. Let's see the definitions. What is a simple event? A simple event or elementary event is an event which cannot be broken or divided further into small events. Okay, the probability of happening of an event or non or happening of a single event is called a simple event. When a coin is tossed, the events head and tail are elementary events. In throwing of a dice, getting the points 1, 2, 3, 4, 5, 6 are called the simple events. Next, compound events or composite events. Compound event is a combination of several simple events. Thus, a compound event can be further divided into the small events. Or if the joint occurrence of two or more events is considered, then it is known as compound event or composite event. In throwing a dice, getting an odd number is a compound event. Okay, in throwing of a dice, getting an odd number. So what is odd number? 1, 3, 5. So that is an compound event. In tossing of three coins, getting a head is a compound event. Okay, in general, compound events are represented in the following forms: A and B, A intersection B, A given B, A into B. Okay, like that. Next, exhaustive events. And events are said to be exhaustive if at least one of them must necessarily occur. The total number of all possible outcomes of a random experiment will continue on exhaustive set of events. Mathematically, two random events E1 and E2 of the sample space S said to be exhaustive. E1 union E2 is equals to S. So the compound. In tossing of a coin, heads and tails are exhaustive events. Uh, in throwing a dice, 1, 2, 3, 4, 5, 6 are exhaustive events, mutually exclusive events. Two events are said to be mutually exclusive when the occurrence of one of them uh, excludes the occurrence of the other. In other words, two events two events are mutually exclusive if both cannot occur simultaneously. Okay, no two or more events can occur in the same trial is called mutually exclusive events. Okay, several or more. Okay, let's see uh, some examples. In throwing of a coin, uh, the heads and tails are stopping. Okay, that is if head is occurring, the another one is getting stopped. Okay, in throwing of a dice, 1 2 3 4 5 6 events are of 1 2 3 4 5 6 are mutually exclusive. Okay, let's see another examples of equally likely events. The outcomes of random experiments are said to be equally likely events if taken into the consideration all relevant evidences. There is no reason to uh, accept one preference to the others. Two or more events are said to be equally likely events if each of them has equal chance of happening and none of them is expected to occur more often than others. Example: in throwing a dice, getting an even number and odd number having the same equal chances, so then they are said to be equally likely events. Okay, uh, if a dice is thrown, what is the probability of getting a number that is 1 by 6, 2 by 6, 3 by 6? Not like that. That is 1 divided by 6, 1 divided by 6, 1 divided by 6 for all other numbers. Hence, it is said to be the equally likely events. Okay, like that we have some more definitions. Independent events. Two or more events are said to be independent if and only if the non-happening of an event affected by the happening uh, of the other events. Okay, independent. Okay, they are independent each other. Okay, all in drawing of two cards from a pack of cards, drawing a card in the second draw is independent from the drawing card of the first draw. Next, dependent events. There exists some relationship between them, so that is called the dependent event. And we will see the sure event probability and the impossible event probability. What is sure event probability? The probability of an sure event is always 100%. That is called 1. Because of our probability value is lies between 0 to 1. Impossible event probability is 0. So up to this is enough, and we are going to discuss some more things in the next session. Thank you.